Thank you, thank you, thank you. All right, hello everyone. I get the privilege of talking to you all right after lunch, so I hope everybody is awake and ready for this. Let me see here. Oh, can you start from slide 1, please? It's on 8. I know it's confusing because it's also a title slide. Oh, I think this might be. Spoiler. Oh, okay. Everybody close your eyes. Well, there's the joke spoiled. All right. Welcome, everybody. Let's get started. So, this is your Go application. And this is probably a more realistic version of it. It's got some Band-Aids. It's a little hairy in some spots. It's definitely got some code smells. But this is honestly what a lot of production code ends up looking like. Now, eventually, your product manager, as they do, tends to have a feature that you now have to integrate into this beautiful mess. Someone on your team, maybe you, suggests it would be faster to start over and rewrite the whole thing. Raise of hands if anybody's heard this before. Anybody? Maybe it's you, it's okay. If you haven't seen this yet, you certainly will. But you're wrong. And I'm going to tell you why that's wrong in 3 points. But first, welcome to my talk, Refactoring Go. Patterns and practices for maintaining large code bases. My name is Brittany Ellich. I'm a software engineer at GitHub. Also do speaking and try to educate people on building better software, stronger careers, and a more inclusive tech industry. Here's what we're going to talk about today. First, we'll go over refactoring and not rewriting. Then we'll talk about how to refactor, which is a systematic refactoring method that I personally use in Go applications that I work in. And then I'll talk about how to go about prioritizing your refactoring methods. And then, this wasn't originally in the talk, but this world moves really quickly right now. So I'm going to include a little bit about how to get AI to help you with this. First, refactor. Don't rewrite. Every single person that I've worked with across multiple companies now probably thinks that this whole talk is about them, and they're all right. It's because rebuilds have been the majority of my career. I've spent a lot of time doing this, and so I've heard a lot of the arguments on why people decide to rewrite things. And I've also seen a lot of times where these go wrong. So first, we'll talk about this one. It'll be faster to just rewrite it. What you're thinking about is probably the feature and maybe a little bit of the rewrite, but humans are really bad at estimating. Has anybody ever estimated a story point and gotten it wrong? Shocking. So there's a lot more to it than you can think of. So you're thinking about maybe 20% of the application, the part that's broken. You have to rewrite the other 80% that's working totally fine. Not only that, there's usually another app at the same time that you also have to keep running and support and not ship features to get this new rewrite out the door. And oh yeah, that whole migration and decommissioning thing, which a lot of people are like, that's the end. That's also a lot of work. It's not going to be that fast. It won't be. Those really quick estimates, when you're thinking about it, turn into very large ones as you get into it. Next, we'll talk about the next one. We're going to move faster with clean code. Here's a look at an app, conceptual one. It's a bit of a mess, but if you can clean it up, it's going to be in this perfect, clean state with absolutely no problems. Here's what this sounds like. If we start over, we can do it right this time. We'll avoid all the mistakes we've made before, and the new code will be so much cleaner and more maintainable. That's never the case. Production applications are inherently messy. That's a feature. That's not a bug. all those ugly edge cases, that's actually your business logic. The requirements that have been gained through user feedback over years and years and years. All those workarounds are institutional knowledge baked into your code base. And there's probably some weird conditionals in there from some 2 a.m. outage solving something critical for a customer that you're probably going to have to solve again. Here's the third one. The current technology stack is holding us back. This is another myth. Here's what it sounds like. We're software engineers. Oh, well, here's what it sounds like. If we rebuild in Rust or whatever your flavor of the week is, it's going to solve all of our performance problems. And our patterns are just too outdated. We're software engineers. We love to learn. It's easy to learn a new technology, but it's really hard to learn it well. And when you pick a new technology for your rewrite, you're going to be doing all that learning at the same time you're rebuilding. So you're probably going to make a lot of mistakes. I would argue that instead of pitching this project as a rewrite and learning this new technology, that you could pitch it as refactoring an existing problem in less time, which would be more impactful than rewriting in a new one. So, refactor, don't rewrite. There are definitely some cases where a rewrite makes sense. I have very strong opinions, but they're very, very weakly held. Anybody here can probably argue for why a rewrite would actually make sense. But if you can't clearly articulate the value of it, then just stick with what you have and refactor instead. You don't need a rewrite. It's going to take too long, guaranteed. All production applications are inherently messy, and you're not suddenly going to work better in a new technology. You're going to make a lot of the same mistakes, but in a different language. The best software products emerge from continuous improvement, not perfect planning. That shouldn't be a surprise. We've been choosing Agile over Waterfall for decades now. So, hopefully I convinced a few of you. Now we'll talk a little bit about how to refactor, a systematic refactoring method that I like to use when I'm approaching a new code base or a new problem. You need to fit that new feature into your application instead of rewriting it. So how do you do it? First, here's a few principles that I like to follow for really any problem. I like to go for easy to read, easy to test, and easy to change. Using those principles, you can pretty much apply it to any problem you're working on. Here's the systematic guide. We've got a few different things you can do here. And somebody that I work with actually put it into this handy acronym. I didn't. He got it good. Here. We've got tests, which is going to be a safety net. Handling errors, which affects the entire structure of your Go application. Interfaces, which define the boundaries of your system. Narrowing your dependencies. Really had to work for the end there. Removing dependencies where you can. Reducing hard coding and using things like dependency injection. And then, keep improving. Continuous improvement is almost always better than big dramatic changes switching to a new application. So, we'll start here with tests. Tests are often a safety net before you change anything. And you might think, my current application is not well tested, so how can I handle that? They're going to guide you through the entire refactoring process. This book is one of my top 5 recommended books for any software engineer, regardless of the language that you're working in, working effectively with legacy code. In this, Michael Feathers describes a process of adding characterization tests. If you have something that's not well tested to begin with, you can add characterization tests around it to just make sure whatever your input is going to equal your output. Just make sure that nothing breaks while you're in the process of refactoring. Next, error handling, which I think we can all agree is very critical to your overall Go application structure. Errors often end up having problems over time, lost context, double handling if you're both logging and returning an error, silent failures if you're not handling an error appropriately at all. This is a great spot to start refactoring the application and trying to find a consistent way to handle your errors. Not necessarily saying that they all have to be wrapped, but having one way that you do it is going to bring the rest of the application together. Over time, the different ways that errors are handled tend to drift, so bringing them all together is a great spot to start. One of the Go proverbs, errors are values. Program with them. Don't just check them. This is really important because they are just as important to your application as values are. Next, interfaces. There's a few different problems with interfaces here, but I think that they're good boundaries, maybe not even specifically an interface struct, but where your program begins and ends. This is really important for making things easy to test and easy to change. So there's a few problems to look at here. Large interfaces are going to force your client to depend on methods that they don't necessarily use. It's going to make it really hard to test and really hard to change because all of the other clients are going to have to change as well. So what we can do is break that down into smaller interfaces specific to what each client needs. Instead of having this user service, which has create user and send email and theoretically a lot of other things as well, you can have a user manager that's just focused on anything having to do with the user, and then a notification service that handles all the notifications. So breaking these down is a good next step. Next, using the any interface when specific types are better. There's definitely some use cases for the any interface. One of them might be marshalling data. But if it's possible for you to add a type, you should always prefer type safety, because the empty interface says nothing. This catches your errors at compile time instead of at runtime, which is great. If you're new to Go, then that means that you're going to see the error in your development environment instead of your user seeing the error in the production application. This also helps with making things easier to read, because now in your IDE, you can hover over processor and see what all is involved in that. Next, narrowing dependencies. I think one thing that's really common in Go is agreeing that it's better to have a little bit of copying and pasting instead of creating an abstraction when it's not necessary. So in general, you don't want to have a ton of dependencies. So here's one example. Adding direct dependencies, which can increase coupling. You can see in this process order, you are opening a database. That means that when you go test process order, you're going to have to worry about having a testing library involved and all of these other things that's going to make it really difficult to test process order. When instead, you can use dependency injection and have process order and all of the database-related logic live in your repository instead. Then, order service, all you got to do is mock, and you don't have to worry about all of the database-related stuff in there. It's going to make it easier to test and easier to change. Next, another example. It's a single struct mixing the API responses and the database concerns and all the validation in one spot. You might think, hey, this is great. We can just have one user and pass it around the application. But if you need to change something in the database, now you have to update your API too. Mixed concerns are really hard to change. So instead, separating them out to what is only important and critical to each package and layer of your application is going to make things easier to change. So you can see here in this user struct, we've got the user API. We only care about things like the JSON value and the validation that's required. And then at the database layer, we only care about what the database values are. Much easier. Next, hard-coded business rules. Offloading any business logic that you know might need to change into a different service is great, because now when the business comes to you and says, hey, I want to change the way we do discounts, you don't have to be involved. If an engineer has to be involved to change something in the code, to change business logic, that's going to slow you down doing anything else that you're doing. So here's an example. Calculating discounts, if you hard code that value to 0.15, that means when somebody comes to you and says, hey, we need to update this. We want to do a 10% discount instead. You're going to have to go and stop what you're doing and change that logic. So instead, make things easy to change. Anything that you think and know is going to need to change, like discounts. I currently work in billing. This is something that definitely will change. It should happen in a service so that you don't have to be involved. Finally, keep improving. refactor as you go. I know this sounds a lot easier than it often is, because sometimes it's really hard to fit these refactoring efforts in when you're also creating features. But we'll come back to that. Continuously iterate and deliver value. And don't wait for an occasional refactoring sprint or opportunity to fit these things in. This is something that I've seen on a lot of the teams that I've been on, where we will set aside a sprint specifically to focus on refactoring and tech debt. But that often means we are putting aside whatever deadlines we have in place. We are completely changing context to look at tech debt for 1 week. We don't take on anything that's too large to fit in with the span of that week, and then we pass it off and often don't end up finishing that within the span of that week. So all around, we just don't fix tech debt. Instead, I argue you should be continuously doing this as you are pushing features. Once again, the best software products emerge from continuous improvement, not perfect planning. All right, now let's talk about how to prioritize these things. I argue the most important thing, if you work for a company that makes money, is to focus on the impact of the changes that you're making. There are a million things you could do, so how do you focus on what's most important? Here's the prioritization framework that I use on my team. You have an x-axis and a y-axis, and categorize each item that you could potentially work on into the amount of effort and the amount of impact. This makes it really easy to quantify. So it looks a little bit like this. We've got things that are high impact and high effort, high impact, low effort, low impact, low effort, and low impact and high effort. Take everything that you're working on and put it on this graph. Then I apply a 3-bucket approach to this. First, start with the high impact, low effort work. This looks like adding error context where it might be missing, just replacing a string, usually pretty easy, extracting some hard-coded values into a configuration, or replacing any empty interfaces with types. Next, high impact, high effort. These things probably need to be planned and prioritized a little bit more, prioritized along with your features. That might look like breaking large interfaces into focused ones, or separating tightly coupled models, or standardizing error handling across your entire code base. Takes a little bit more time and you gotta plan for it. Finally, the 3rd bucket, low impact, any effort. Just ignore them. You're probably never gonna have time to actually work on them. Until it becomes a high impact problem, it's probably not worth the time to spend on it. Until getting AI to help you. Because would this be a talk in 2025 if I didn't at least mention AI? Also, I've been informed that in Germany, it's KI instead of AI, in case that is more relevant to you. So this is the method that I've been using to refactor with agents today. I'm not going to talk about this too much. We can talk about it later if you want. But GitHub recently released the coding agent, and working there, I got to dog food it a lot, which if you've never heard that term, it just means I get to use it a ton internally so we can test it before customers do. This agent is really cool because you just type up an issue and assign it to Copilot, and it creates a PR. So there was no setup involved. You just do it. Here's some of the use cases that I use it for. Increasing test coverage, searching your code base to find inconsistent approaches, or taking patterns and applying them across your code base. And I'm going to show you a few examples of things that I've done doing this alongside feature work to refactor and reduce tech debt. Oh yeah, and this blog post just came out. It was written by me, so if you want. We can also talk about it later if anybody's more interested, but you can check out a recent blog post about how the GitHub billing team uses the coding agent in GitHub Copilot. So, increasing test coverage. This is the prompt that we used. In order to build more confidence in our code changes, we should try to get as close to 100% as possible in our test coverage, search the test files in the lib services directory, and identify if there are any paths that aren't currently tested. Create table-driven tests to cover those scenarios. And you copy and paste a reference to what you mean by table-driven tests, written by somebody in this room. Note that I'm specifying a specific folder so that it doesn't go crazy, and that makes a huge difference. You can also add additional context with articles if you want to have more information on how to do it. Worked really well. Next, searching your code base to find inconsistent approaches. We wanted to standardize error handling throughout our application. You can paste in a code snippet and say, use this, apply it across all of the files in the lib services folder. And it works pretty good. I mean, obviously, you have to review it, but sometimes it'll go a little bit off the rails. But it works really, really well. Next, use this PR as an example to swap from the existing mocking library to this new one for mocks in the lib services directory. In this case, you can create a PR of a small change, paste it in with your prompt, and it can apply that systematically through different parts in your code base. There's basically no excuse not to continuously handle tech debt anymore. And it's very exciting to me as a developer to finally take some of these issues that would otherwise go to our backlog to die and complete them while I'm delivering features. It's super cool. I don't even work in like the sales of this. I'm just excited to use it as somebody who uses it regularly. It's really fun. So, a recap. Refactor, don't rewrite. 3 different arguments. You now know why they're wrong. How to refactor, applying the think method at each space. How to prioritize your refactoring by focusing on impact. And how you can use AI tools to help you refactor today. And because it's worth saying again, because we come back to this, the best software products emerge from continuous improvement and not perfect planning. Got a few acknowledgments, of course. My partner is watching my 3 kids so I can be here, which is awesome. And the team that put this conference together has done a phenomenal job. And I'm really enjoying GopherCon EU. I have some GitHub colleagues who gave me some great feedback. And a shout out to Bill Kennedy, who suggested this conference to me. And that's mostly why I'm here. And then also to my brother, who's here today. I appreciate you coming out. Here's resources.